Alright, I'm back. And now with sound, I believe, right? Yes. Alright. I still have a beautiful microphone in its original box that I'm not using yet. Laziness knows no end. But anyway, let's at least talk a little bit after so many silent episodes. So I was philosophizing here because maybe I was procrastinating on the coding. Could be. Well, let's get something. These are good ideas though. I like these macros as unfrozen functions or semi-frozen. That's a better way to put it. We'll get there. So let's just try a very basic sequence, something like we can do something like yeah, cannot get easier than this. +1. +1 is do. I will get the result here would be int 1. I'm laughing. Why am I laughing? Because I remember when I saw C functions, and the C functions where you specify the type and the type of the things you pass in, and also the type of what they return. And this thing reminds me a little bit of that. Sometimes, no matter how much you want to avoid something, you end up repeating the echoes of what you grew up with. Although I didn't grow up with C, I just picked it up later. Anywho. So this will give me this, and then I'm going to define it as plus, add plus. I need to implement plus, by the way. No small task, that's a good one. 1. So let's just do int 1. Yeah, and then we would do something. This is dot terge. Yes, brilliant. 11 would be +1 10, and this would be 11 really. Yeah, perfect. Yeah, these dots are essential, otherwise this is quite confusing, right? Let's try the test. Is there a better way to do it than this? It will have to be with text. Okay, let me see if this is worth it. No, because I don't have multi-line lines, right? There would be to this. Inner count 1. If count, is this more readable? And of course I forgot these ones. And doesn't work. That's weird. Here come 1. Ah, because it takes the indentations, I will have to do them here, right? Yeah, that's pretty ugly. Let's pick the new lines. Okay, we're done. Disregard. Yeah, you really need the internal representation to be first class for data. That's why we're here, right? Yeah. So we're gonna set some stuff now. I guess technically we could already do the setting. No, but I don't want to do it like that. I want to do it. Would be. I want to do it the other way around. I'm putting 11 as plus 110. And I want to put plus 1 to be. I kind of like it as only 2 lines here. Plus 1 is add 2. Int is the name I gave for the integer that I'm passing to it. I need another line like this. It should be the same, except that it would be 1. Yeah, like this. And when I'm getting this, I'm expecting to be 11 equals 11. Still you have the adds. It's so cool to see the formula and the results coexisting. I cannot get over how much I like that. I just can't. I'm very happy with that. I'm very, 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 very happy with that. Let me switch the music. I love this record, but we need, I think there's, yeah, exactly. I want to jump to this one. Maybe this one. No, this one. Yeah. Plus count 1. What am I doing? Plus 1, of course, as an equal int 1. It's funny that I will write this down. It's funny that I love variadic functions, and yet in cell you can only pass one argument message to a call. So yeah, I mean, if you want several things, just pass a list. And know the structuring, I think, for now. Or a hash, you can pass a hash too, of course. And the structure from the top. We'll see later if we want to relax that. For now, let's get something working. So this is doing, I think it's not dots anymore, no. Doing one at plus 1 1. No, sorry, that's wrong. You would be, sorry, I need to do the expansions here, right? No. Plus, the problem is I'm coding all day, so when I get to this time, I'm a bit slow. 1 at plus 1 at int, and then the same thing pretty much, except that the last at is a 1. And this actually doesn't even include the expansion, right? Which I should put here. What's the expansion here? The expansion would be int is 10, right? Yeah, of course. And the sequence would be, it will be at plus, which would of course yield 11 and then I will get add int yeah. I think that's it. So not out int. So this is 10 plus 1, it gives you 11. Yeah, that's the expansion, right? Sequence 1 equals 11. This is interesting, I have to say. But plus 1 equals 10. Then I'll have to replace I was just looking in the shape here. It's very interesting how the shape develops, right? With the results on top, the bridgements. It's just funny to look at it. Here we go to the 2. just a 1. I believe that's it. So all sorts of interesting properties depending on the amount of calls. You have more lines. Yeah, cool. Okay. Okay. Well, it definitely doesn't do what we want to do because we haven't implemented any of this yet. Wait, what? +1. That's the call. Yeah. Where does a +1 like loose? Where is this coming from? +1. Ah. That's a bit weird, isn't it? Where's this? How does this plus and the 1 get separated here? Ah, because I just did like this and silly goes here. Okay, let's fix it. Okay, a bit better now. Okay. Okay, let's implement stuff. So we have to do the walking. Well, this one doesn't require walking. It's just I would think that if I didn't know this was a big deal, it wouldn't feel such a big deal. So that. Yeah. Never gets called. That's weird. Of course. Yeah. So we get plus at do in the context of +1, which is actually interesting. Correct, I believe. Technically, it should go 1 up, but it doesn't matter. It's okay. actually, technically we should go one out. Let's do it already. Because the place where you're calling, but wait, how do I know? So I'm getting it at the plus. I have it multiple times. It's always the same. So what I want to understand is the 11 one, right? It tries to get +1 and 10. Yeah, that's the problem already. It should give me... I need to do the walking already, of course. That's the problem. I need to get the +1 first. The value path is whatever is to the right of the rightmost adds. Yeah. So in the case of if there's an if somewhere else, it's okay. I don't need anything special. I can just look up its value and we will get it, right? Yeah, because we jump over the equals with this one here. So that's fine. Well, if I'm looking at the time, I must be having a bad time, eh? Let's see. Is it really that hard? No, it's not that hard. Come on. It's not that hard. Come on. I am lacking an intuitive feel for how things expand on every single iteration. When you have multiple things with adds, how it gets drawn. That's what I'm lacking. If I look this, this one is interesting. But if I'm always working on the rightmost part, why am I not going to the previous ones? Because the rightmost gets expanded to an equal one. That's how it works. So, right, it has to be. Let's say you have two adds in a line, right? So just two calls. So first you just look at the rightmost add and you add an equal on it. You put that. Then when you go at it again, you take the line that has the equal and still has one add, and then you add another equal. And then it's done. And that's how you do it one at a time. Instead of having to look at all the adds in one path, you just do it iteratively. Did I explain this somewhere? I honestly don't remember. I think I was just doing the low level mechanics here. Now you may be asking, what happens when a path has two or more adds? How do we deal with these paths if our logic just looks at the rightmost add only? What is that's a better place to put it. The answer is the following. The rightmost add will get a new path on top of it that has an equal. So it is this path that will get its add the next to last rightmost add expanded. This can happen until all adds in one path get expanded path by path onto one that has only equals. Yeah, that's why. Okay, so now I understand more what's going on here. So I'm looking at this. Yeah. Why did I do all the expansion here? Because I want to know the result, right? Okay, let's just do it here again. Becomes 11 will be plus 1, 10, and then plus 1 is 2 in that's it. Sorry, I've messed up again. All right. So now what? So how is that relevant? This okay. So the first time around, I'm trying to resolve this the rightmost plus 1 and 10. So what I need to do is I will first get plus 1 and 10. If I don't get anything, rather than giving up, I will try to get plus 1. If I get something that's a subtle piece of logic. I'm processing 11 plus 1, 10. Try to get plus 1, 10. You get nothing. Then get plus 1. If you get something, and that something is starts with a do, wait, plus 1 is, no, it gives you int 1, so I don't even know that. How would I know that this is a do? I will have to look at the expansion. Replacing equal with at. And that starts with the do. Take that value and put it in JS and go into actual do mode. If you get something that is not a function, you still return empty, because we only do the walking up for calls. Function is a call. I'm having a tough time. I don't know why, because it's flowing. Yeah, why? Let me switch the music. Oh yeah, no, this one. You're walking up for calls. But not even. Let's direct. Call is direct to do. Put the argument message name and the number of steps, or a validation error. This walking would have to be done in this case. Okay, I'll be right back. Okay, I'm back. So where were we? Yes, the walking. Yeah, last time. This is a mess, sorry. Living free. I need to understand the data flows. Why is it happening so many times, this +10? This is the first one. Yeah, I kind of get it. Okay. So first get everything, and then if not, shop them, right? So the current value should be the at. It's okay to get rid of all the equals for the indirect references. It will be data stop, data times. You need to do it on value path length times. We have negative ones. Yeah, we do. Start 0. Value path slice 0 minus k. We should work, right? Yeah. Yeah. So we just get this. So when I go get +1, it's gonna give me an equal. I could search in +1 at, right? So sorry for the nestedness here. I can already start at 1 here. Can be a bit more explicit there. And I need to concatenate and add. With value length, return value. I wonder if I have to validate something more concretely here. So it will have to be an add do, right? I guess I could just do this. Boom, right? So if I get something from +1 add do, I get the hash right then and there. Lo and behold. Yeah, that would be very explicit. And I need two functions really. One to if op is defined, do some stuff. I'm almost done. I'm gonna finish right here. I'm going to leave it a bit of a cliffhanger. But basically, one is gonna be calling it there. So do execute, and here would be okay, we're gonna leave it as is. Yeah, my bad. Okay, not bad. See you next time. Thank you for watching.